The cosmos, an infinite canvas painted with wonders and shrouded in enigma. For millennia, humanity has gazed upwards, driven by an insatiable quest to decipher its deepest secrets. Today, that quest accelerates, as new eyes and groundbreaking missions pierce the veil, promising to redefine our understanding of existence itself. Soon, a new giant will join our celestial fleet, the Nancy Grace Roman Space Telescope. Named after NASA's pioneering chief astronomer, Roman will offer an unprecedented panoramic view of the universe, capturing images so profound they are set to revolutionize astronomy. This next-generation observatory is not just looking for distant galaxies. It's designed to directly image exoplanets, a monumental step in humanity's search for life beyond Earth. But before we gaze into the cosmic abyss, let's turn our focus closer to home. A powerful eye, born from a remarkable collaboration between the United States and India, is already revealing Earth's hidden pulse. The NISAR satellite, launched just last year, uses advanced radar to peer through clouds and darkness, tracking the subtle shifts of our planet's land and ice. And what it reveals is astonishing. Recently, NISAR captured a breathtaking image of East Antarctica, where a mountaintop pokes through a river of ice. The stresses from this obstruction have fractured the surrounding glacier, creating deep crevasses that, through NISAR's unique radar vision, form the stunning outline of a hummingbird. This isn't just a beautiful picture. It's a profound insight into the dynamic, unseen forces shaping our world, revealing what lies hidden beneath the surface. From Earth's hidden depths, we leap back to the dawn of time, guided by the incomparable James Webb Space Telescope. JWST has peered into the infant cosmos, uncovering the secrets of early galaxies, cosmic factories that tirelessly pumped vital stardust into the nascent universe. This stardust, made of elements heavier than hydrogen and helium, was the very foundation for the birth of new stars and the eventual growth of galaxies like our own. Unable to directly study these primordial processes in detail, astronomers used JWST to observe a nearby dwarf galaxy, Sextans A, a perfect chemical proxy for the early universe. Here, they found specific dust factory stars, massive red giants, churning out the heavy elements essential for future generations of stars and planets. This groundbreaking research, impossible before Webb, paints a more complete picture of how the universe evolved into the complex tapestry we see today. As we continue our search for life beyond Earth, new research is refining the very definition of a habitable world. Scientists have discovered that a rocky exoplanet, even if perfectly positioned in its star's habitable zone, must be large enough to cling onto its precious atmosphere. Too small, and the life-sustaining blanket of gas simply drifts away into the void. The critical threshold, it turns out, is roughly the size of Mars. Planets smaller than this struggle to retain an atmosphere for the billions of years needed for life to emerge, due to weaker gravity and less internal geological activity. However, the study also revealed that a planet's carbon content, a thicker mantle, or even a cooler starting temperature could significantly boost its chances of holding onto that vital atmospheric shield. Yet, even for worlds that lose their initial atmospheres, hope remains. Comet and asteroid impacts could deliver fresh volatile elements, seeding a second chance for an atmosphere to form. This ongoing refinement of habitability models ensures our cosmic search becomes ever more precise, guiding our telescopes to the most promising candidates in the vast, mysterious expanse of space. The universe continues to unfold its wonders, one discovery at a time.